Okay, we're now at section 12.2, and we're going to be introducing the idea of matrices. In a way, matrices in general should be a review for us because we did deal with them in Algebra 2. But this idea of an augmented matrix, we're going to talk about that. Performing row operations on a matrix, we're going to deal with that in this lesson. And then solving a system of linear equations using matrices. This will be something that you haven't done before, but it's going to involve this idea of performing row operations. And just to kind of give you a preview of where we're going today. At the very outset, the first block of problems are going to be pretty simple. What this represents is a system of linear equations, and we just spent some time in the previous lesson solving these using either substitution or elimination. Well, what it's talking about with an augmented matrix. Anybody know what the word augment means? It means to add on to. That's one way of, there's several different similar ways of explaining augmenting something, to put something as an attachment onto something. So really what that idea is, if you think about it, we have a matrix that consists of these four terms separated by these equal signs, and then in a way there's another matrix on the right. Okay, so this idea of an augmented matrix means we're going to make a 2 by 2 matrix using the coefficients on the left side of the equation. So that would be 1, -5, just the coefficients, 4 and +3. And we're not going to do a completely separate matrix. This is where we attach, and so we're going to just draw a vertical line, and we're going to show the numbers on the right side of the equation on the right side of that line. So in essence, what we're saying is we're kind of treating these as two separate matrices that are glued together. A matrix that has been augmented by another matrix representing these constants on the right side of the equal sign. So again, here's another example. It's just going to be a 3-variable system, but it's the same idea. The top row would be the coefficients 1, 1, and -1. And then we would draw our line essentially where the equal signs are and put +2. Close my brackets. Okay, so remember this first column should just be x coefficients. The middle column should be y. There is no z, so we'll put 0 in the z spot. And then this last row would be 5, 3, -1, and then +1. So that is what is known as an augmented matrix. How to take a system and rewrite it in that form. Okay, then you get to the next block of problems, and your directions will change, and I just copied them down like they appear in your book. Write the system of equations corresponding to the augmented matrix. Okay, so we'll just do that first sentence first. That would be this system. We have 1x minus 3y equals -2. So we're essentially going backwards from what we did in the previous set of problems. And this would be 2x minus 5y equals 5. So we just did the first sentence. We wrote the system of equations corresponding to the given augmented matrix. Now we're going to do the second sentence. It says perform the indicated row operation. So let me just kind of give you verbiage to help you understand what this all means in green. What this means is row 2 is going to become a brand new row after we do this. We're going to multiply -2 times each element of row 1. Then we're going to add that result to row 2, and that is going to replace this row 2. that we're looking at. Okay, so notice row 1 is not changing. So when I write this new matrix to show these row operations, I'm not doing anything differently to row 1. But row 2, according to this, is going to be changed. So we can do some mental math here. We'll just go one at a time. If I multiply negative 2 times row 1, that makes negative 2. 1 times negative 2 is negative 2. And then if I add that result to row 2, what do I get? Negative 2 plus 2, that makes 0. Okay? So somebody raise your hand and tell me, after you perform the row operations, what would go here? Okay, what is that, Cody? Okay, everybody see how you got 1? Negative 2 times negative 3 is 6, and 6 minus 5, or plus negative 5, is positive 1. Okay, somebody else besides Cody, tell me what goes here. John? Okay. Yeah. So each individual element multiply by negative 2, and then after you do that, add that result to the row 2 corresponding to it. So why don't you try helping me with this. John, what do you think? All right, so he did negative 2 times negative 2, that's 4. 4 plus 5, 9. Everybody get it? Because we're leading up to something, and this kind of thing is going to be necessary to solve systems, this kind of thinking. All right, let's try another one. First of all, according to the instructions, we need to write the system. So let's just go ahead and do that real fast. Shelby, what's the first equation of my system? Very good. And Emma, the second equation? And Ruthie, the last one. Okay, so we've taken care, I'll just call this answer part 1, and now let's do answer part 2. We're going to do the indicated row operations. Okay, so rows 2 and 3 are going to change. Row 1, according to this, is not changing. I'm not doing any kind of modification to row 1. So let's create row 2 according to what's being described here. We're going to multiply negative 3 times row 1 and then add that result to row 2. So Stacy, I'll just go one at a time. What goes in this spot? 0. All right, Bailey, what would go here beneath negative 3? Okay. Everybody with me? She multiplied negative 3 times negative 3. So you're doing negative 3 times each element in row 1, and then add to row 2. So negative 3 times negative 3 is 9, and 9 plus negative 5. These will be given. Yeah, now eventually, when you're solving, it's going to be up to you to figure out what to do. And I'll show you what I mean by that in just a minute. So Cody, what's going to go here underneath the 4? Good. And Bailey, what about here on the other side of the line? Good. And Shelby, what about here in this bottom first column? 0? Everybody say we got 0? So it's negative. For row 3, now we've changed the rules. For row 3, we're multiplying 5 times row 1, according to this, and then add that result to row 3. 5 times 1 is 5, and 5 plus negative 5 is 0. Okay, so Ruthie, what about underneath the 4? Negative 12. And Stacy, what about underneath negative 6? 24. And we'll go back to John, our final piece. Everybody got it? Any questions? Once you've done a few, it gets pretty easy. Okay, we're going to end today's lesson, and I've modified the instructions just a little bit, and I'll tell you why in just a minute. This method is called, for us, it's going to be called row echelon form. And the reason why I marked out the reduced is because we're doing kind of a shortened version of reduced row echelon form. So first of all, let me kind of set up where we're going. The whole idea is to take a given augmented matrix, whether it's a 2-variable system or a 3, and we're supposed to make it look like this, where I have, if it's a 2-variable system, I'm going to have 1s diagonally in these spots, and a 0 here, and A, B, and C represent just regular numbers. If it were true reduced row echelon form, then I would have 0s here, and I would just have the 2 1s. Okay, but we're going to simplify this just a little bit, and that's why it's really just called row echelon form. So those of you who are, I'm not sure if anybody's going to pre-cal, but this will be hit again in pre-calculus, and I've seen it also in some college algebra classes. Okay? Here are the rules. Got to know the rules before you can play the game properly, and there's 3 big rules. In order to accomplish this, you can switch places with any 2 rows. Just pick them up and move them if you need to. You can replace a row by a multiple of that row. That's kind of what we were doing before in our little exercise. We were multiplying 5 times a row. And then number 3, we were doing this as well. You can replace a row by the sum of that row and a multiple, as long as that's not 0. Can't multiply by 0, of another row. Okay, so let me just walk you through a couple of examples how this is going to work. So first of all, you're going to be given a system. You need to think of that system as an augmented matrix. So I went ahead and did that for us. Okay, remember, the goal for a 2-variable system is to turn our given augmented matrix into this, using row operations. Well, it's kind of nice because this top 1 is already provided. So the strategy here that works best is to work down and come up with this 0 as your first move. Okay, so I'm going to make this 0 first, and then what does this need to become? It needs to be positive 1. And once I've reached that, I'm ready to solve, and I'll show you how that works. So let me just walk you through this first example. I want you to number your steps and describe how you get from one matrix to the other. And here's what I mean. So to make this 0, I'm essentially just going to do row 1 minus row 2, and this means put that result in row 2. So this is the way you're going to describe each step. All right, notice row 1's not changing. It's staying just like it was. But when I do this, after I do this, it will completely replace what I'm showing currently as row 2. So row 1 minus row 2, 1 minus 1 is 0. 1 minus negative 1 is 2. 8 minus 4 is 4. Okay? What else has to happen before I am in row echelon form? Cody. The 2 has to become 1. So my next step, and again, I need for you to describe it for me and then actually do it. My next step is going to read 1/2 times R2. So row 1 is not changing. Row 2, multiplying 1/2 by 0 doesn't mess up my 0 that I've already placed there. 2 times 1/2 is 1. 4 times 1/2 is 2. Okay, now think of this as a system. As a system, this would be x plus y equals 8. My top equation really didn't change. What would the bottom equation be? Y equals 2. So we just solve for y. And now you can do backwards substitution, pretty easily solve for x. So if y is 2, what does that make x? Yeah, if y is 2, backwards substitution, you just go up here and plug in 2 for y and subtract it from both sides. And so that's my answer. Any questions so far? Okay, that was a pretty easy one to get us started. Let's try a 3-variable system. So again, the first thing you should do is go ahead and write the augmented matrix form of this system. So 1, negative 1, 0, 6, 2, 0, negative 3, 16, 0, 2, 1, 4. And once again, this is nice because our first location, this first spot has to be 1. It already is. So that's good for us. What else? Looking at your 3 rules, knowing what we should accomplish. And by the way, your strategy should always look like this. Make zeros here first. And then come over here and do the 1, 0. So you're kind of doing it in this order. Take care of this column, and then take care of this column, and working across that way. Because what some people do is they'll find this 0, and then they'll do an operation to turn it into something else. You see what I mean? So again, the game is to accomplish 1s diagonally, and then you should have this triangle of zeros. All right, so looking at your rules, what would you suggest we do next? There's not there could be a wrong answer, but sometimes there's multiple good answers. Any thoughts? I need a 0 here. Well, did you see on your rules that you can interchange any 2 rows? You see that? So what if we just replace or switch places with 2 and 3? And to say that, you're just going to do this. Just do a double arrow. Row 2 and row 3 are just going to switch. So row 1 is good so far like it is. Row 2 is going to go down to row 3's place, and I'm going to move row 3 up. Okay, now my next move, I should just go ahead and complete this column. I need to have this become 0. So any thoughts? This will be called step 2. Stacy? Nice. 2 times R1. Subtract that from row 3, and then show me that's going to go, when you do that, that's going to go in row 3. All right, so rows 1 and 2 aren't affected by this step. All right, so here's row 3 when I do these row operations. 2 times row 1, which makes 2, and then subtract row 3 minus 2. That gets the 0 for us. Here it's 2 times negative 1, which is negative 2, minus 0, it's still negative 2. 2 times 0 is 0. You got to be careful here, you're subtracting negative 3. 0 minus negative 3 is positive 3. Here is 12. 12 minus 16, which is negative 4. Okay? So far so good? Now I'm kind of running out of room, so I think if somebody will read that off to me, I'm going to go to a new slide. Can somebody read that? Ruthie, can you read that off? Somebody. Okay. We just changed that one. That should be 0, 3, negative 4. Does that look good? I write the right numbers. Okay. So again, when you finished, we finished this column. It's set up the way we need it. Now I'm going to target this one. And what's that supposed to be? It's supposed to be 1. All right. So give me my operation. This is our third move. Stacy? 1/2 R2. And then give me the matrix that results. One half times 0 is still 0. 1/2 times 2 is 1. 1 times 1/2. 1/2 times 4. Haven't done anything yet, in this step anyway, to row 3. All right, now, again, I'm going to complete this column, and I'm going to focus on this negative 2. It's supposed to be what? 0. So, Shelby, what do you think? How can I turn that into 0 using row operations? Cody, what do you think? Trying to make this 0 using our rules. We don't make them, you just follow the ones I gave you on that slide. So, well, I'm using multiplication and addition subtraction to force these numbers to become 0 or 1. So I'll just go ahead and help you out. I'm going to use row 2. Since I got to make this become 0, I'm going to say 2 times row 2. And then I'm going to add that result to row 3. And then that will replace row 3. Why did I not do -2, for example, times row 1 and add that? Wouldn't that also have given me 0 if I'd used row 1? But what else would that have done? It would have taken the 0 that I've already created and made it something else. So I would have undone previous work. So you kind of see how that works. That's why it's a better strategy to go in this order. Get your zeros and then work on the next column working down. Okay, so with step 4, first row doesn't change. Second row isn't changing. Third row is going to become 2 times row 2. 2 times 0 is still 0. Plus row 3, that makes 0. 2 times row 2, 2 plus -2 makes 0. 2 times a half is 1. 1 plus 3 is 4. 2 times 2 is 4. 4 plus -4 is 0. And we just got one more move, and we will have our reduced echelon or row echelon form. So Ruthie, what do you think? What's the only thing preventing us from being in our final augmented matrix form? One thing stopping us. So Cody, what are you showing me there? The 4? It's got to be 1. I got to have 1s diagonally and then 0s below. So Shelby, how am I going to do that? Got to turn 4 into 1. One-fourth R3. Yeah, if I multiply the third row, that's what this means, all the way across by 1/4, it's not going to change my zeros because 0 times anything is still 0, but it is going to cause this to be 1. Feel sorry for Z. Okay, we're there. So now we can do backward substitution. We know what Z is. What is the solution for Z? Because this equation, if it were a system, this bottom equation would be Z equals 0. What would the middle equation read as if we just lifted that line out? It would be the second equation in a system. Bailey, what would it be? Okay, so let's solve for y. We know what z is. Oh, I don't know why I wrote 0. So Bailey, what's y? Okay, so our answer is going to be an ordered triple. Okay, John, this top row represents an equation, and what would that equation be? Yeah, just if you were rewriting that as an equation, it would be okay. Well, we know what y is. Now let's solve for x. We found y. What's x? Very good. Have you seen enough to kind of get the grasp of what's happening? You think this is kind of fun? Yeah, and it's going to take a little practice because you've probably never done this before. But give yourself a little bit of time, and the more you do it, it's like anything else, the easier it gets. And I'll definitely help you if you need it. Let me give you a couple of heads up. Okay. Remember dependent and inconsistent. We talked about those. Let me give you a couple of examples. When do you know, using row echelon form, that you're going to have dependent? Okay, so I'll just kind of make up a matrix here. All right, remember that's our goal. Ones down this way. Triangle of zeros, numbers up above the ones. Okay, this would be a good system. This has an answer. Actually, it has 3. But if in the process of making this happen, I get this, it's unavoidable. Where the whole bottom row ends up being zeros. This is when you have the dependent situation. And going back to what John and I talked about earlier, this is any ordered pair that would be on the plane, or in this case it would be ordered triple. Infinite number of solutions. Well, I'll just use this same augmented matrix to represent inconsistent. If the bottom row ends up all zeros, but then over here we have something. We have a number. Whatever. This is inconsistent. In other words, this is the no solution. Okay, so I just want you to understand, hey, I'm down to the bottom and I got a row of zeros on the bottom. Well, the answer to that is automatically going to be, this is a dependent system. There's an infinite number of solutions. And this is the no solution. This is like saying 0 equals 11, which isn't true. Okay? I'm going to turn you loose on some problems, and I need for you to make a modification. I meant to put this on your slide, so make sure you just write those 2 down at the end, because I didn't type them up. And if there's anything I can do to help you, let me know. I'll put some answers up so you can check your work as you go.